So this is the second part of, or the second talk in a series I'm offering that I hope you find useful. We established the role of what's going on with the warming ocean and so on. I want to turn now to the past a little bit. I want to put the next three slides, looking a little longer time scale so you have appreciation. There's nothing special about where sea level is today, which is the right image. If we go back not very long ago, geologically, 120,000 years, we were in the previous interglacial. Sea level was about 20 feet higher. Almost all that melt was from melting of the West Antarctic ice sheet, as far as we understand. And then we started to move into a cooler condition because of how Earth presented herself to the sun. And we worked ourselves into an ice age, and sea level dropped as more and more snow fell on land and didn't melt, making huge continental glaciers. And by 18,000 years ago, sea level was down over 420 feet. The continental shelves were entirely exposed, and it looked like the center photograph map. And the really important question to thinking about the future is, how do we get from that 420 feet lower sea level to today as we moved into the present interglacial period? And it turns out it wasn't just a gradual pickup and then slow down. It was a series of discrete pulses all across our continental shelf. We have old barrier islands, old reefs that would form at still stands of sea level. And then they would just be drowned out by a rapid pulse of rise. And every one of these vertical pulses of rise, which you can see we've recorded through the whole of the post-glacial maximum to the present period, every one of those pulses is because of the rapid disintegration of some ice sheet sector and associated rapid rise of sea level, and then a pause and then another rise. And that's important because that's how sea level works in a warming world in the presence of ice, which we are in now. The next slide is from 400,000 plus years ago on the left to the present on the right. And the upper red diagram shows the carbon dioxide concentration that you can find if you drill into the ice sheets. The atmosphere is trapped in little bubbles as the snow accumulates, and you can drill in and get out year by year record of what the composition of the atmosphere was, and we can do that for carbon dioxide, methane, and so on. And so these are direct recordings of our former atmosphere, and you can see there are times where the atmosphere was up around 280 parts per million carbon dioxide, and there are times when it dropped down to 180. And it did this at very regular, about 100,000 year intervals, and warming and cooling. And this is how we presented because of how we presented ourselves to the sun in terms of being more circular or oval in our orbit. And you can see how we worked from that 20-foot higher sea level 120,000 years ago to the glacial maximum. We worked our way down and then sort of shot out of it. And at the end of the beginning of the Industrial Revolution, we were right at about 280 parts per million. In concert with that, we have a record of sea level that we've worked out other ways. And you can see through this period, and this goes back about 1 million years, you have about, you're going up and down sea level rise from plus 100 to minus 100 meters, about 100 meters up and down in concert with these warmings and coolings because of how we presented ourselves to the sun. And this is all natural. This has been going on through geologic time in various ways. Beginning of the Industrial Revolution, we were at 280 parts per million. We increased it over the last period of time, most of this in the last 100 years. We increased from 280 to 380 to 421 today parts per million. That's more than double what it took from 180 to 280 to affect 100 meters sea level rise. We don't have 100 meters of sea level rise left. We only have about 70 meters if we want to melt all the polar ice, which we probably won't do. But nevertheless, what would you expect sea level to do in response to this? Nothing? Just a little bit? No, that's arrogant and not right. Not at all right. We're in for something serious. And in the previous slide, I just showed you how it will work in series of rapid pulses of rise as some ice sheet sector disintegrates. Since about 1993, both Greenland, shown here, and Antarctica have started a dramatic rate of melt. And here's an example from 2003 to 2019. You can see the number of average meters of ice lost or gained in the blue per year. And you can see in areas such as here near the Jacobshaven ice fjord coming out that there has been somewhere from 3 to 6 meters of ice per year, okay, lost. That's lowering the elevation of the ice sheet. That's adding water to the ocean. Okay, and we've had almost a millimeter of global sea level rise being added per year from Greenland alone now. And it used to be back in 1980s, nothing. Okay, the next slide, there's a little red dot there. You may or may not be able to see it. But flying in on the ice sheet beyond the Jacobs-Asian ice short, you can see this stuff. You can see this. You can follow the fjord deep beneath the ice sheet because it's melting from below because warmed ocean water is getting in underneath and causing melting. This is 500 or 600 feet below the level of the ice sheet that you see in the distance. And that's what's happening on both Greenland and Antarctica. This warmed ocean water getting in around the ice sheet and it's causing accelerating ice melt. Same thing is happening in Antarctica. And the areas of special interest are the Pine Island Glacial Outlet here and the Thwaites Glacial Outlet. This is often called the Doomsday Glacial Outlet. And there's another one that you might want to look at. I don't know what I did. How did that go? Larger. I don't know. There we go. The Toten Glacial Outlet on the east side. Also, warm water is going in under or over 100 miles in under the ice sheet. This Thwaites Glacial Outlet is a deep concern. If we were to melt all of Greenland, we'd raise sea level about 25 feet. If we were to melt the West Antarctic ice sheet, we'd also have about 25 feet. The East Antarctic ice sheet is more, but hopefully less active for a while. And as I said, this is the West Antarctic ice sheet is where most of the melt came 120,000 years ago to cause our 20-foot rise of sea level that we had. The Thwaites Glacial Outlet or the Pine Island look like this. There's a rock sill. The weight of the ice inland has pushed the land down. And beginning in about 2009 or so, we started to get warmed ocean water coming in over that sill and detaching the ice from this sill. Originally, the ice was jammed against it, so everything was sort of stable. But as the warmed ocean water has gotten in and causing melting, it's detached the ice and it's breaking apart quite dramatically. Here's another picture that was just created for the Thwaites because we're very confident that we're very shortly going to detach from this ice, this ridge, this rock ridge, and just having warm water pour in. It's not that warm for swimming, but it's warm enough to do powerful lot of melting. Okay. So what I've tried to show you is that our coastal future really depends on what happens in the polar ice, which is happening because of what we have done in burning fossil fuels and building up greenhouse gases in the atmosphere, which is then transferred to the ocean. And the problem is I've tried to show you that the stability of the polar ice is very rapidly fracturing and melting away. And so we're in for real trouble. Probably we have initiated a new pulse of sea level rise. Last time we were above 400 parts per million CO2. Remember, we're at 421 right now. Sea level was about 70 meters, about 70 feet, 21 meters higher. That was 3 to 5 million years ago. But that's where we're headed because of what we've done. And there's no way around that. And we should be prepared to save the things we can't afford to lose. Our National Archives, the Smithsonian, is on the Mall in Washington, which is filled just about like the fill areas on Miami Beach or Western Broward County. It's swampland that was filled. And all these other things, military bases, seed banks, disease control centers, energy systems. We should be planning for the rapid resettlement of large population groups from rising sea inundating coastal areas and other climate change things. And probably most important, we should be worried about maintaining agriculture functionality and distribution as sea level rises. Most of our deltas are huge resources for agriculture, and they'll be inundated and saltwater intruded with less than 6 feet of rise. So we have a choice of making this a progressive, orderly process in which there can be both planning and help for the affected families, businesses, and communities as they no longer can function where they are, and cleaning the land before inundation. Or we can risk catastrophic chaos, creation of huge numbers of dislocated indigents. Read about the Dust Bowl if you don't remember what happens to dislocated indigents. And something we rarely talk about, polluted new wetlands and shallow marine environments. We have all kinds of dumps along the coast and in low-lying floodplains that are becoming increasingly affected. And these are very critical to do something with so we don't leave behind for us and our kids and our grandkids and so on a highly polluted new shallow marine environment. The choice is very much ours. Thank you. I add this slide in case you're in a higher elevation community, because we should be really worried. You should be really worried about us coming, because we will come and you can prepare for it. You should be setting aside your parks and preserves, make sure you have clean water, deciding how large a city you can handle waste disposal, energy. Your city. If you don't, we're just coming and going to make a mess of it. Thank you.